All right, welcome everybody. This is Calculus's Unit 1, Assignment 1A. This is dealing with lines. The assigned problems are here up on the board. What I'm going to be doing now is just pretty much going through the problems pretty quickly. This should be a review for most of you of things. So this is just the assignment kind of going through it. All right, so we begin with slope. So again, what slope is denoted by the letter M, which can be found a couple different ways. A very generic, like in essence, counting way is you count the rise between two different points and the run between two different points. And then if it's going uphill, it's positive. If it's going downhill, it's negative, which would be indicative of the rise, but this is how you would find it. Or a formula for such would be y2 minus y1 over x2 minus x1. This will all get you the rise. So looking at our very first problem here, problem number 1, we see that we have several concrete actual intersection points here. So we have various points. So what I'm going to be kind of doing is I'm going to be looking kind of at this formula right here. I'm kind of looking at the rise over run kind of way of finding slope. So what I do is I pick out 2 points. And so the slope of this line is it has a rise up and down of 2, a run side to side of 1, and it's going uphill, thus it's positive. So this slope is positive 2. In number 3, again, look for concrete points. Just select any 2 of them. It doesn't really matter. I'll select this point and I'll select this point just to be kind of weird. And so we see that this is kind of what is created here. So looking at our rise, okay, our rise, our up and down, we see that that has a rise of 3, and a run, the side to side, it has a run of 3 as well, and this line happens to be going downhill, so it's negative. So negative 3 over 3, aka negative 1. So we have slope given a graph. Finding the slope of a line in exercises, these exercises, plot the points and then find the slope of the line that passes through them. So 3, negative 4, so 1, 2, 3, 1, 2, 3, 4, 3, negative 4. 5, 2, 1, 2, 3, 4, 5, 1, 2, right there. So plot the pair of points and then find the slope. So the slope in this situation would be counting. We have 1, 2, 3, 4, 5, 6. Run of 1, 2. It's going uphill. So this is positive 3. I would actually probably do this the mathematical way, the algebraic way, where I would take. Sorry. I would identify the points. As such, and I would do y2 minus y1 x2 minus x1. So that would be 2 minus negative 4 over 5 minus 3. So this would be 6 over 2, aka 3, as we found before. Like I probably wouldn't actually plot this out if I had my way. Moving on to number 7, same problem. So plot the points. We got 4, 1, 1, 2, 3, 4, 1, and we have 4, 6, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 4, 6, and so this slope has a rise of 1, 2, 1, 2, 3, 4, 5, a run of 0. So 0 when the 0 is under, it's undefined. Okay, so the slope is undefined. It's a vertical line and it has a slope of undefined. again, the little trick is if it's under, it's undefined. If it's over, and then it's over. Okay, it's over. Okay. Boom. Moving on. Oh, good. Same problem. Find the slope. Like so. Like it really wouldn't make much sense to do this. Like by looking at the picture. So what you would do? So like if I needed to do this, it'd have an x coordinate of -3, 4. I'm looking at this this second piece, second point. It has a x coordinate of -3/4 and a y coordinate of 1/6. So it'd be like, I don't know, in there somewhere. And then we have -1/2, +2/3, -1/2, +2/3. Like, and so there you go. I plotted some points. Okay, but how are you actually going to find this slope? And so y2 minus y1 over x2 minus x1. And so this is what you would get. You would probably want to use a calculator for this, but just in the world, let's pretend calculators are broken. So we have a 1/6 as a denominator, so that'd be a 4/6. And here we have a denominator of a 4. So this would be what, 2 as such. And so this would be -3/6 and -1/4. And then flip the bottom up, so that multiplies to that, that multiplies to that. That's that sort of thing right there. So this would be -12 over -6, which is 2. Again, using the calculator, that will hopefully tell you the exact same thing. The numerator is 1/6 minus 2/3. So that's that. So this is going to be divided by -3/4 minus -1/2 and 2. There you go. All right, in these next exercises, find an equation of the line that passes through the point that has the indicated slope, then sketch the line. Okay, here is where you want to use the point slope formula. This is the kind of formula that you are going to be using for an equation of a line. So other equations of a line that you may have used is y = mx plus b, which is an awesome thing, but the problems that we're going to be seeing over and over and over again in calculus don't follow that basic idea. Usually they give you something where they give you a slope and a point, and they're implying that you know the point slope formula, which is y minus y1 is equal to m quantity of x minus x1. And these two equations are the exact same thing. However, you don't need 2 points and you don't need a y-intercept to make this tick. All right, so using this as my example. So y minus y1, so the y coordinate is 3, is equal to m, which is 3/4, x minus x1, which is the actual point of 0. So I do this, I distribute this 3/4 in, and so this is 3/4 x minus 0, and then I add 3. So all I did is I added this 3 coming across, and there you go, you got your y = mx plus b type formula using the point slope. Okay, now they want us to actually graph this, so the y-intercept is 3, rise of +3, run of 4. There you go, booyakasha. It goes off the graph and there's arrowheads. There you go, got your line. So again, write the equation of the line. So m is undefined. That is pretty much indicating that this is going to be x is equal to. And so looking at the point, I see x is equal to -5. And so there's your equation of an undefined line. And so x is equal to -5, 1, 2, 3, 4, 5. And then this is going to be, and that's supposed to be a perfect vertical slope, but that's your equation of that line. That's your picture as well. Okay, last but not least, number 19 down here. Number 19, so y minus y1 is equal to m x minus x1. There you go. Distribute that in. Minus 0, add 0. There you go. Y is equal to 2/3 x. So there's your equation of a line. You can kind of think of it as being plus 0 if you really want to think of it that way. So I see that the y-intercept is 0, rise 2, run 3. Moving on. Okay, n is equal to 0, so that is an indicator that this is a y is equal to 4. You can still do it the point slope method. This is going to be a horizontal line, but you can use the point slope method. Y minus y1 is equal to m x minus x1. So 0 multiply in is 0, add 4. There you go. So you get the same thing. So anyways, y is equal to 4. 1, 2, 3, 4. And then x is equal to 4. Boom. All right. Excitement. Nothing but excitement. Find the slope in the y-intercept if possible. So again, y is equal to mx plus b. So I see that the slope is 4 and the y-intercept is -3. Here I'll manipulate this, number 27, I'll manipulate the equation. So I'll subtract 5x. So subtract 5x, and y is isolated. So I see that the slope is -5, and the y-intercept is 20. Number 29, again, this is an undefined slope. Okay. So what this picture would look like, just kind of go where x is equal to 4. 1, 2, 3, 4. Okay, so there's x equal to 4, and this is an undefined slope. So I know that the slope is undefined, okay, because it has no run. And the y-intercept is, there isn't one. There's an x-intercept, but there is no y-intercept. It never touches the y-axis. Sketch graph of the equation. Y is equal to -3. There it is. Y-intercept of 1. Rise of -2. Run 1. Okay. This one gets a little tricky. Let's just take a look at it. So I'll write it a little bit larger here, and we'll investigate this one just a little bit. All right, so 2/3 x minus 2/3 with the distribution, and then I add 2. All right, so when I add 2, what I'm going to do is I'm not going to add 2 as this. I'm going to make it look like this fraction right here. So I see that I need a denominator of 6. So or excuse me, a denominator of 3. I'm getting ahead of myself. It needs a denominator of 3. So 3 multiply up would be 6. Okay, so if I need this to be 3, I need to multiply by 3 to make that happen. So I multiply by 3 to make that happen. Okay, so you're a little rusty on your fraction skills. All right, so I add 2, quote unquote 2, which would be 6/3. So this is going to be y is equal to 2/3 x, -2, so this would be a positive 4 over 3. All right, now, so positive 4/3 would be 1 1/3, so there's my y-intercept of 1 1/3, rise of a complete 2, so 1, 2, and a run of 3, 1, 2, 3. There's your line as such. Okay, so what they're really trying to get you to figure out is this. If you find these points, and they're going to be opposites, so the x-coordinate is positive 1, the y-coordinate is positive 2, you plot that point, and then it has a slope of 2/3. So that's kind of what they're trying to get you to figure out. Okay, here this one is just going to be straight up manipulation. So what I'm going to do is, the easiest way is actually just to move this y, make the y positive. So add the y to the other side. So I'm technically adding y over here, think of it as, and so this is still going to be a 2x and a -3. So this still has a y-intercept of -3, rise of 2, run of 1. Easy peasy lemon squeezy. Find the equation that passes through the points, sketch that line. Okay, so I do need to figure out a slope, so y2 minus y1 over x2 minus x1. And then I use the point slope form, so I'm just going to pick one of the points, it doesn't matter which one, pick one of the points, and then y minus y1 is equal to m x minus x1. So this is 2x with the distribution plus 0, and then I subtract 5. So y-intercept of -5. Okay. And rise 2, run 1. More problems, same thing. Okay, so slope okay, that's a good one. All right, y minus, I'll choose that point. Y minus y1 is equal to m x minus x1 is this positive 40. So what I'm going to kind of do is I'm going to kind of use this method right here, this method of thinking when I graph this. So think of this point slope form that I have written right here. So I see that the x-coordinate is positive 5. The y-coordinate is 0. And I have a slope of -8/3. Okay, slope of -8/3. So 5, 0, 1, 2, 3, 4, 5, 0. So otherwise, I would have had a point of 2, 8. Just kind of putting this 2, 1, 2, 3, 4, 5, 6, 7, 8 off 1. So this is what I have. And so if I have 5, 0, yeah, and so I have a slope of -8/3. So I go down 8, go over 3, which would be the same thing as going up 8 and over 3. And so I am hitting all the points that I'm supposed to be hitting, and that's how you can graph it. Finding parallel and perpendicular lines, write the general forms of the equations of the lines that pass through the given points, parallel to the line and perpendicular to the line. All right, so parallel. Implies that the slopes are the same. Like 1/4 is equal to 1/4. All right, so if you know the slope of one, you know the slope of the other. In the perpendicular, it's an opposite reciprocal. So something that would be an opposite reciprocal is if I have a slope that is 3/4, that would imply that the perpendicular slope would be -4/3. So opposite, that would be the positive turning into the negative, and the reciprocal, which would be a 3/4, is a 4/3. All right, so here, the slope of a line of x is equal to 1 is undefined, aka this has a slope where the slope is like it has a rise, but it doesn't have a run of something. So you can kind of think of it like that, or if you just kind of know equation things, you can see that a perpendicular slope m would be equal to 0. So so here the parallel equation would be x is equal to -7, because I have to use this point. And so it would run through the point of -7 too, but is parallel because it has the same slope of undefined. All right, so the parallel is x is equal to -7. The perpendicular equation is going to have a slope of 0. So that means y is equal to. And the only thing y could possibly be equal to is -2. So we kind of start you off with a tricky one. All right, so in the second one, I see that the slope is currently -1. The slope is currently -1. So the parallel equation is going to be y minus y1 is equal to m, which is the same thing, x minus x1. So this is -x minus 3 plus 2. And so y is equal to -x minus 1. There is your parallel line going through -3, 2. I'll do this one right here, perpendicular. Notice that that would imply that the perpendicular slope is 1 over -1, which is still -1. Okay. Perpendicular. See, I'm stupid. I'm sorry. Take that back. Yes, the reciprocal would be 1 over 1. However, it's an opposite reciprocal. That didn't make any sense. All right, so I'm sorry. Yes, the slope is a positive 1. All right, so here we go. This implies y minus y1 is equal to m, x minus x1, which is a -3, so plus. And so this is x plus 3 plus 2. There's your perpendicular equation. All right, kind of speeding up the process here. So we got -2y is equal to -4x plus 3 divided by -2, 2x minus 3 over 2. So this currently has a slope of 2. All right, so parallel line. It means it has the same slope. So y minus y1 is equal to m, x minus x1 and then our perpendicular equation is y minus y1 is equal to m. So that's -1 over 2, because again, this is a positive 2 over 1, so opposite, negative, reciprocal, 1 over 2. X minus x1. So this is negative 1/2 x plus 1 plus 1. There you go. We have to kind of be getting close to the end now. All right, here we go. Analyzing a line represents the equation ax plus by is equal to 4. What is the line parallel? What is the line parallel to the x-axis and y-axis? All right. Okay, I'm just going to kind of manipulate this equation here just a little bit. So this would be by is equal to negative ax plus 4 divided by b. Y is equal to negative a over b plus 4 over b. When is the line parallel to the x-axis and y-axis? Excuse me, this doesn't x on here, I'm sorry. So when is it parallel to the x-axis? All right, so parallel to the x-axis, that would be y is equal to some number, and that would imply that a is equal to 0. So when is it parallel to the x-axis? That implies that a is equal to 0, and that's the only stipulation. And b cannot be equal to 0, I guess. That'd be the only stipulation. Because what you want is you need this a over b to go away. You need that to be 0. So that would be y is equal to 0x plus, some constant, some number, any number. It doesn't matter which number, as long as it's a number. And the way that you can make this second piece into a number is if b is not equal to 0. That would be undefined. But that would imply that y is equal to some number that is aka parallel to the x-axis. Clean up my mess here just a little bit. And then last but not least is when is it parallel to the y-axis? So that would be something like this. And parallel to the y-axis, I should have thought of that simpler. Just need to think about the original equation. I'm sorry. Parallel to the x-axis. Parallel to the x-axis means parallel to the x-axis means y is equal to. So this obviously means a has to be equal to 0, and then b has to exist. Okay, and then the other form of the question is when is this parallel to the y-axis? And so a parallel to the y-axis is up and down, aka this is an x is equal to graph. So again, thinking about that, we need that to go away. So when it's parallel to the y-axis, that would imply that b is equal to 0, then a cannot be equal to 0. That's the stipulation. Sorry about that. Okay, give the values a and b such as line has a slope of 5/8. Okay, now is where I kind of bring in the idea of what I was thinking about before. So if this has a slope of 5/8, that would imply that A is equal to 5 and B is equal to 8, one of them being negative. There you go. That has a slope of 5/8. Perpendicular to that. So if my slope, again, from right here is negative A over B, all right, and I need it to be negative 5 over 2, that would imply that A is equal to 5, B is equal to 2, or A is equal to negative 5 and B is equal to negative 2. Coincides, that means it's the exact same equation. So kind of cheating backwards here just for a second. Y is equal to negative A over bx plus 4 over b. And I need this to coincide with 6y is equal to negative 5x plus 8. Y is equal to negative 5 over 6x plus divided by 6, that would be 4/3. Okay, let's go to work. So I'm kind of cheating off of this, and I'm going to make this equal to 4/3. So I'm going to just make my b is equal to 3. And so if that's the situation, I need this first equation to be negative 5/6. Or here's how I'm going to cheat the system. I'm not going to reduce it. It's going to make my life a little bit easier. Okay, so again, yeah, I need to start with this second piece. I need to make 4 over b equal to 8/6. So this has to happen. So 8b is equal to 24, b is equal to 3. It has to happen that way. Otherwise, I can't make that y-intercept be the same. So b has to be equal to 3. All right, so in that situation, what I need is I need negative a over 3 to be equal to negative 5/6. That way, I get the same slope. So cross multiplication again. 6, 8. A is equal to positive 5 over 2 divided by 6. Now those lines coincide. Boom. Yeah, ta-da. All right, so that's the lesson. Sorry that it took so long. We did it in 30 some odd minutes. Most of the problems are pretty easy. Make sure you do your homework, and we'll talk about turning it in at a later time. But make sure you do your homework.